So today is day 2 of section 14. We're going to talk about the volume of 2 of our 3-dimensional shapes. So we're going to talk about the volume of prisms and the volume of cylinders. So prisms and cylinders are basically the same thing. The difference is a cylinder has a circle for the base. I'm going to draw this here to indicate that it does have that circle at the bottom as well. And prisms can have squares or rectangles or triangles or whatever as their top and the bottom. So the volume is similar to the area of a square. You take the area of like the base and then you just multiply it by how high it is. So the area of this base, let's say area of the base times its height. Its height is how tall it is. The if it's a cube or rectangular prism, the volume is just equal to length times width times height. I put area of the base there because if the base is a triangle, then it's not length times width times height. If the base is a pentagon, then it's not length times width times height. But most of the time, prisms are going to be in the form of a cube or a rectangle, like a box. So if it's a box, how about that? If it's a box, we're going to use length times width times height. The area of a cylinder is still the area of a base. Now, we have not talked about this in detail, but we need to know the area of a circle first, because these bases are circles. So the area of a circle is pi r squared, where r is the radius. So the volume for this cylinder is the area of the base, which is going to be pi r squared times h. So, an example. Leo bought a fish tank, 37 inches wide, 24 inches long, and 15 inches high. 1 gallon of water fills 230.4 cubic inches of space. How many gallons of water will the fish tank hold? So, I need to know how much will fill it up. So, I'm going to make a little note here. Volume is how much fits inside. So if we want to know how much the fish tank will hold, we do volume is equal to, this is a box, it's a length, width, height one. Length times width times height. So that's going to be, what's the length? 24, 37, and 15. So 24 times 37 times 15. Take my calculator, punch in 24 times 37 times 15, and I get 13,320. And this is in cubic inches. That's just the units that we use for this volume. So if the tank contains 4,440 cubic inches of water, what percentage of the fish tank is empty? So right now there are 4,440 cubic inches of water out of a total of it can hold being 13,320. To find the percent, I just divide those numbers and I get 33.3 repeating percent is full. So if that much of it is full, that means that 66.7% is empty because it has to be 100% between the two options. So I took 100, subtracted that to get 66.7% empty. Oh, sorry. There we go. So that much is full. I took 100 and subtracted what was the amount full to get how much was empty. Okay, so our cylinder example. Katie Cake's cat food company needs to decide how to package their premium cat food. They've narrowed their choices down to 2 different containers. One container is a prism with a height of 4 and a 2x2 inch square base. Another container is a cylinder with a height of 5 and a diameter of 2. Which container will hold the most cat food? I'm going to draw a picture here. So I'm going to draw the first container that is a prism. They told me that the base was 2x2 and that the height is 5. So I got that right here. So the volume of this container is 5 times 2 times 2, which equals 20. So that is 20 cubic inches. Compare that to the cylinder. The height is 5 and the diameter is 2. Diameter is all the way across the circle. So that is 2 times the radius. So since diameter is 2, R is going to equal 1. The volume of my cylinder is pi r squared times h, which is 5. Another thing to make a note of, we have a pi button on calculator. But it is equal to 3.14. And you will be told when to leave it in terms of pi versus when to plug that in. Since I'm comparing something that does not have a pi in it, I need to go ahead and use the pi button to figure out exactly without that ratio in there, if it's bigger or smaller than 20. So I'm just going to multiply my calculator. Let y'all watch. I'm going to say, well, 1 squared is just 1. So it's going to be 1 times 5, which is 5, times, and then I'm going to press pi, equals 15.7. So, which one's bigger? The cube is bigger. Or the rectangular prism. It's not a perfect cube. So this one is going to hold the most cat food. Okay, so I have turned the page to day 2, part 2. Still talking about prisms and cylinders. We are just now talking about surface area instead of volume. Surface area is around the outside of the shape. So it's all the faces, all the bases, the area of those added together. So it's kind of like when we split a shape up into triangles and rectangles and we combine all the different areas. We are going to be combining all the areas of our shapes here. Surface area is the sum of all the surface areas of each of the sides and bases. The lateral area is like the label on the soup can. It is just the sides. It's not the bases. So I'm going to jot a note here that it's like the label on a soup can or a Coke can or whatever else. So find the surface area and the lateral area of the prism below. So the surface area. I'm going to take these, find the area of each one, and just add them up. So the surface area, this first one is 10 by 2. It's a 10 by 2 rectangle. So that's going to be 20. And all 4 of these are exactly the same. All of these are 2. These are squares on either side. So a 2 by 2 square gives me 4. And 4 on this side as well. So all I do is add up 20 plus 20 plus 20 plus 20 plus 4 plus 4. 20, 40, 60, 88. The lateral area is just the sides. It's not the 2 bases. So that's 20 plus 20 plus 20 plus 20, or 20 times 4 gives me 80. Okay. Now we have this cylinder. Cylinders are more difficult to find the surface area of because we have to do a little bit of work to figure out how long that side is. So I'm going to first find the area of the bases of the 2 circles. So they're circles, so the area is pi r squared. So that's pi times 10 squared. So that gives you 100 times pi. The area of the face is going to be 30 times something. What that times something is equal to, if we take this circle and we roll it along, if we unfolded the circle, if we made a cut right here and unfolded it, it would be the length. So we need to know the perimeter of the circle, which is called the circumference. The circumference of the circle is equal to 2 pi r. So for this circle, that's going to be 2 pi times 10, so that's 20 pi. So that is the length of that rectangle. So the area of the rectangle is equal to 20 pi times 30, which is 600 pi. And then we just add them for the surface area. Total surface area is 100 pi for one of the bases, plus another 100 pi for the second base, plus 600 pi. So it's 600, 700, 800 pi total. Which, if I put that in the calculator, 800 times pi, that's going to be about 2,513 centimeters squared. That was a lot of work. We technically have a formula for the surface area of a cylinder, and I'm going to put that up above. Surface area is equal to two times the area of the bases, pi r squared, plus the circumference, 2 pi r, times the height, h. It's a long formula. That's why we did not use it the first time around. There's a formula for the area of a rectangular prism as well for a box. So surface area is going to equal 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Okay. So moving on from numbers 1 and 2 down to number 3. Determine the lateral area, surface area, and volume of the regular hexagonal prism with apothem of approximately 3.5. So this is going to combine what we did in section 11 with area of regular shapes. So the first thing I'm going to do is find the area of the base. It is the hexagon. It has 1, 2, 3, 4, 5, 6 sides. The area of the base is 1/2 A times P, apothem times perimeter. So that is 1/2. The apothem is 3.5. And the perimeter around this is 4, 4, 4, 4, 4, and 4. So that's going to be 4 times 6 sides. That gives me an area of 42. The lateral area is all rectangles around the side. So to find a rectangle, I need the length and I need the width. We know it's 3 feet. 3 feet here. That one's 3. So we're going to do 3 times, and then each side is 4. That's 3 by 4, that's 3 by 4, 3 by 4, and so on. So each rectangle is 12. But we have to take 12 and multiply that by how many rectangles there are. There's 1, 2, 3, 4, 5, 6. So we're multiplying by 6 because there's 6 sides to get 6 times 12, 72. So that's the area around the sides. For the total surface area, we're going to add our 2 bases, so 42 plus 42. We have 1 base on the bottom, base on the top, plus 72. And that gives me 156. It also asks for the volume, so we're going to find that in a second. You remember the volume is the area of the base times height. We already found the area of the base, thankfully. It's 42. And the height is 3. So that gives me 126. And the volume is in cubic feet. The area is in square feet. And that is it for day 2. It's it for prisms and for cylinders.